We're expanding on the use cases. People are thinking a lot more creatively. We're throwing quantum at different problems and trying to understand where it could potentially have that advantage.
Quantum computing is a fast-moving field, and not just when photons are involved. I wanted to get a sanity check from someone I respect on a wide range of recent developments and potential future outcomes. It's safe to call her a superstar in our field, and she's come a long way since I met her at one of my talks a decade ago. I'm joined by the incomparable Anastasia Marchenkova, and halfway through, I think she starts to interview me. I hope you enjoy this longer format episode of the Post-Quantum World. I'm your host, Konstantinos Karagiannis. I lead quantum computing services at Protiviti, where we're helping companies prepare for the benefits and threats of this exploding field. I hope you'll join each episode as we explore the technology and business impacts of this post-quantum era. Our repeat guest today is someone that everyone should have known, even if she wasn't on my podcast before. I'm talking about my longtime friend, Anastasia Marchenkova. Welcome back to the Post-Quantum World.
Yeah, thank you again for having me on.
Yeah, you're one of those special people in this industry that I could literally talk to about anything and trust the answer. So what a perfect guest to have come back.
I'm so glad that's the reputation. I try really hard, and it's the hype in the industry is out of control in some ways. And so having these conversations where we do have these back and forth and are allowed to debate and be wrong and have this nuanced, I think is so important for the industry right now. It's not as clear where in other industries you can go, hey, we have this feature. Oh, right, they do have this feature. There's proof there, right? So there's been a lot of very interesting developments in the field the last couple of years.
Yeah, I agree. And if there was anyone I would want to start off with some debunking, I guess it would be you. So I want to put you right on the spot, completely unprepared, and ask you about any recent hype that kind of drove you crazy. And you're like, why? Why are they saying this?
Any reason? The thing is, I have friends everywhere, so I don't want to offend anyone. So
yeah, so do I. I know I'm always in that spot. Yeah. Everything's great.
Tough, but you know what? I really appreciate. So I always think the scientists are really great, and I think that has always been great in the industry. Where no matter where I've been, no matter how the marketing department has gone off on their own deep end of what they're doing, the scientists have always been super legit across the companies. And I think that's part of the physicist training. So I got my bachelor's in physics. I went for my PhD in physics. Physicists have this weird thing where someone will ask them, like, is this true? And it's like, well, yes, it's possible in the context of the universe, but words mean very precise things. And that's where physicists are actually very, very honest, which I'm sure also drives the execs crazy, the investors crazy in some way because of the precision of that language. But I've always been very excited about how the scientists have all come together to try and talk about the hype. I mean, obviously, the big conversations have been across the big giants with the Microsoft announcements and the Google announcements end of last year as well. But at the end, I think again, the scientists all know what's going on. There's good conversations going around online. And most of the comments are pretty throwaway. I think actually it's gotten a little bit more competitive in the industry lately, especially in the last year here. So I think more of these statements are being pushed. But again, without the what can I say? It like without the proof behind it, right? It's a little bit hard for anyone to take it seriously anyway. So it's not like they're coming out saying, we have a 1 million qubit chip that does this thing and we've proved it and we have X amount of revenue. Like that obviously can be very falsifiable, but some of these little more colorful statements, I think a lot of it in the end is storytelling, right? We were taught that as we're building up startups and everything, that some of it is about selling the vision. So I think that's the thing. You have to balance that with the truth of where you are. So yeah, very interesting time.
Yeah, the wildest. I mean, it all started with Willow. That was the beginning of the wild claims.
Yep.
They had to throw in metaverse, right? that there's a multiverse kind of idea. They had to throw in 10 to the 25 years to some, and it got people very excited. I still can't believe how that caught on.
Yeah. So it was a very interesting story, right? And there's some statements there. And I think, again, as you and I have been in the field for so long and we know this, we recognize these as some of the original scientist words as well that have been hyped up a little bit. But It started with Willow. We saw the stock prices go up. Then we saw Jensen crash them back down
Yep,
again.
yep. And then
So,
announce he's going to have a day for
yeah.
quantum.
I mean, I had so many friends text me. They're like, well, I got like my quantum stocks have been doing so well. Like they saw the Willow stuff going on, they got
Mhm.
in on it, and then and I was like, you know, guys, be careful. Here's my input here. I'm not going to tell you what to do with your money, but be careful. Like I understand this is a lot of hype, and they're like, no, but I made 30% this week. I'm like, great, and then Jensen crashed it back down. So I was like, yes, this is, you know, a lot of this is very volatile. There's not a lot of companies in the public sphere that are doing a lot of this quantum technology work. So a lot of balance. This is not financial advice, as we
And
say.
as we record this very close to when it'll post, no one is making 30% in any aspect of the stock market right now. Yeah,
Exactly, right? So
they're
it's
losing 30% sleep maybe, but they're not making any 30% gains right now.
everyone's saying that, well, I made this thing and the stock went up 4% this week, so let's annualize it. I'm like, nope, that's
Yeah.
not what's going to happen.
So when you were there with Jensen, how did that all play out for you? What did you think about the fact that he so quickly said, no, 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 just kidding. We're going to have a quantum day for NVIDIA.
Yeah, so it was super interesting. So I was very lucky to be invited there as part of the press for NVIDIA GCC and be in a separate press event with Jensen as well. So I got a lot of these little insights there. And he's a brilliant person. I mean, he's absolutely has this vision. He thinks 20 years into the future. And obviously, as we know, people have been in the field. There's a lot of our friends working at NVIDIA in the
Mhm.
quantum space, right? So the fact that, you know, they're like, well, quantum's not around, obviously not. They're working towards it. They see a vision towards it. A couple of the announcement, especially the first day, the keynote, I started getting very excited about. I'm like, oh, I'm hearing silicon photonics. That immediately perked me up. Oh, they copper's a problem. I'm like, oh, okay, so we're seeing this. I see how this becomes the grander vision. But he also made that statement there, right? Oh, I didn't know these quantum stocks were public yet, so I didn't know my words would affect this. So I think that was interesting. So I really truly believe he didn't mean to cause any of this chaos. I think what he said for his purposes, which is he is looking at the future, the AI infrastructure right now, you know, he's leading the pack there. For quantum to get to that time, that is decades away, right?
Yeah.
But, you know, short-term applications, we all see things are moving forward at a good pace, even actually a quick pace in some ways. But there are a lot of these infrastructure challenges that a lot of us have to solve, and then NVIDIA has to implement before they can really bring quantum into their space. So I'm excited about that. I was really interested in his keynote as well. I think a lot of the things that we heard there were very basic, but I really appreciated how he challenged people on that and the perception and actually pushed them beyond what I was expecting, maybe towards the end. But I think it was a good time to get everyone on stage and talk a little bit about the industry and see how it all fits into his grand plan.
Yeah. So while he might be right that, that true mass scale utility is years away, we're seeing little signs of hope that quantum computers will start doing useful things, right? I'd love to hear your thoughts on the D-Wave paper, which seems to be holding up, sort of. Everyone who challenges it challenges some kind of like reduced subset of it and tries to extrapolate. They don't really challenge it properly, in my opinion. I don't know if you've seen anything.
Which one actually?
So the supremacy paper, this idea that D-Wave did something useful. Yeah, the magnetic simulation. I don't know if you heard any, stirrings, anyone.
Yeah, so unfortunately, I wasn't able to attend their demo day, but I have been working with a few startups. So what I do right now is I advise a lot of early stage startups, and some I do advise to use the D-Wave system because for their purposes, it is maybe a nearer term play that they can actually work with and maybe a cheaper play for them, right?
Yeah, totally.
That's super interesting. So yeah, I'm working with multiple startups that are seeing really good results. Their end clients are seeing maybe not, revenue generating results yet, but are seeing results enough that they're very, very interested in moving forward on this. That to me is already great. I think they're moving forward in a really good way. I think they're a little bit underestimated. I mentioned which one because there's also an interesting blockchain paper that they released recently.
Yes, the first, the quantum blockchain. Yeah, of course.
Yeah,
yep.
So I was like, whoa, okay, I have to.
That's totally cool too. Yeah.
out of it. So yeah, there's a lot of interesting applications there that they could potentially do. And in the end, the client does not care what quantum computer runs on, what modality it is. It just has to work. So
Yeah.
I'm very happy with the experiments that are running. Again, I talk to their main team pretty often. We just see each other at conferences, every couple of months. I'm like, what's your update? Send me your new case studies. But yeah, we are seeing really interesting results on things like medical imaging on the annealing side that I think that's very, very cool. We'll see if that's the long-term play, right? Maybe some other modalities can catch up. There's been a lot of new modalities that are kind of coming out of the woodwork. Some results, it used to be all about superconducting qubits. Now it's, trapped ion hype and neutral atom hype is up really high in the last couple of years
Oh yeah.
as well. And then, at some point it might spin back as well. Every modality has such like different challenges. So I think D-Wave has gotten to a more stable phase where they're figuring out a couple more of those problem sets and working closely with these startups that are moving forward in specific spaces. And that was always my thesis. It's application specific because
Mhm.
quantum computers are application specific processors in a way. And so we will figure out uses for some of these modalities, at least in the near term. Long term, we'll see.
Yeah, when you count companies that are actually using something in some type of production, I don't think anyone comes close to D-Wave. There's so many companies willing to go on stage and be like, "We did this, we did that. We're Ford, we did this with our cars. We're Volkswagen, we did this with paint."
Yeah.
It's always
And that's
impressive.
huge. And that's definitely huge because even on decks, right, I see early stage companies saying like, oh, we stole a client from this big giant that claims to be doing this application, but we were able to steal them because we were just better in this like certain application. We were able to play with the modalities and compare them across hardware. And actually, Jensen said that as well at the press event, which I thought was interesting. He said, who's the smartest person in the world? And no one responded. He says, or do you know who it is? And he's like, well, do you care? No, you don't really care. You want the person who knows the most about the certain thing that you're trying to fix. You don't actually need the smartest person. You need that domain expert. So as I see these early stage startups starting to go into these specific places, that actually a good place to start. They have access now to all the tools that are able to actually play around and figure out where they can actually get advantage in different spaces. And another rant probably for later, but I think quantum advantage is also an interesting term that people have been using that we can also talk about.
Yeah. We're going to definitely go there. The other things with this year that I'm excited about is you mentioned neutral atom. With Microsoft, for example, Atom is expected to have 50 logical qubits
Mm-hmm.
available in Azure Quantum. That's pretty amazing.
Yeah.
That's a magic number. That's like the number of qubits you can't simulate past, right, on a classical system, pretty much, give or take.
Yeah, so it's actually interesting. So this is something I've been actually thinking about on the. I'll challenge you a little bit on that, which
Sure.
is something I've been thinking about and working on. I've actually seen the rise now, application-specific quantum simulators.
Hmm.
So there's a way to actually reduce the amount of calculations you need to do to actually go up to, I've heard, up to 200 qubits on the simulator side, which is actually very interesting at that point. If you can do it for a very specific application, again, a customer doesn't care if you can do both finance and some other thing. If they're not in the finance space, they don't need that. What if you could build that simulator? But yeah, Adam's been doing an amazing job on
Hmm.
this, like slow and steady, building up the race. Yeah, that exciting 54 qubit logical qubit barrier. QR, I believe when they first announced it, it was 34 something, maybe 24. That was a year and a half
Yeah,
ago.
like a year. Yeah, yeah. Hmm.
Year and a half ago. It's going to be interesting, right? So what does logical qubits mean? So I feel like we keep getting into this like terminology debate every single time. Physical qubits, but what's the difference between these physical qubits and those? What's a logical qubit? Can you say it's a logical qubit if it just error corrects? What type of error correction does it have
Yep.
to count? Does the gate error correct? Like so many extra layers, and now we're fighting that battle.
And how much of a slider does it have, right? Like, I want it to be logical, or just logical. Like when you're sliding, like how much tolerance is there, and what does that really mean? How deep a circuit can you get in the end? I
Yep.
mean, there's a lot of unknowns. It's not like neutral atom right now is known for having deep circuits,
Yep.
right? That's not exactly what modality would point to and go, look at all these things that were done. There's no famous example of that I know of.
And yeah, there's a lot of other parameters on that. And then the question is, well, when will we hit that scale? And then what will we do across that? I think there's a rise now. There's only been one paper I saw 6 months ago. I think another paper I saw recently But the question is, okay, so how many qubits can the system actually practically fit in? 10
Hmm.
years ago, we were talking about, yeah, we can print a million qubits, put it in a dilution fridge, right? Oh, we can do this. But even 2 years ago, the scientists were saying, like, we don't know how do we fit more qubits? So now it's been this rise, this conversation of like modular systems. And I think IonQ
Hmm.
has been talking about this for 5 years or so. That's
Oh
always
yeah.
been kind of in their plan there. But okay, so we get those 54 qubits in one system. Can we actually get to 1,000 logical qubits, or do we have to start building algorithms that can take these systems and put them into multiple at a time? So I think that's really interesting because that's not how we do algorithms research right now. So now you
Hmm.
have to completely rethink the algorithm side as well, if that's how the system's going to work, and like even the classical bandwidth requirements at this point, you have to start like thinking about.
How invisible will interconnect be in the end, right?
Yeah,
Like,
yeah,
will
and
it
then
be, yeah, or will it
yeah,
be this whole bunch of software complexity that, like you said, we're not practicing for right now. We're not tuning our circuits for right now.
yeah,
We're not even like showing it. But Psi Quantum, their idea was the same thing. It's going to be a big box with little boxes in it. They wouldn't
yep,
give me an exact count of how many qubits are in each of those boxes, but they know that they can't do it all in one big open field.
yep.
So how do we scale up? That's a challenge. As far as that simulation you talked about before, would that be a true state vector though?
No, it's not a
Simulation.
full state
Yeah,
vector.
yeah. So
But
that's where
again,
the limitation is. Yeah.
right. But if it's close enough and it's better and it's faster for their purposes, nobody cares, right? Again,
Yeah.
so it's very interesting. From what I've heard, there are revenue generating activities from things like that. So I think
Hmm.
that's a very interesting thing, which to me, in some way, is quantum advantage. Like we're showing it if, quantum inspired or some systems can bring any sort of, improvement. I think that's actually really great.
Yeah. The other quantum inspired example I saw that wasn't state vector would be this company Quantum Rings. Had them on,
Mhm.
and they're doing tensor networks and some kind of sampling and such. And they were able to recreate the first Google paper, the 2019 paper, and run it in 2.5 days on a laptop,
Wow.
which is
Yeah.
insane. That's certainly not 10,000 years or whatever the claim was.
Right.
Yeah.
And I think it's still going to be important, and why I think this is still a field that should be pursued, even though people are saying, well, the machines are scaling up, is because these systems are going to be small. Like they're still going to take up a lot of space, at least for now. We're going to have data centers. I don't know if you saw that economic analysis report, which was super interesting, that I looked at. But basically, you're not going to let a junior software engineer be like playing around on the real quantum computer coding algorithms. So we're still going to have to figure out how simulators work to even get people like
Hmm.
coding on these systems. So I still think that's like a very interesting long term play, that people should be looking into researching, because that's going to live alongside the quantum computers to be able to like actually work on production and scale it up. Yeah.
So, do you think now with this whole AI coding, you know, track that everyone's on right now, where AI is just taking over more and more of the coding, do you think that the only jobs really left are going to be when it comes to coding, like true algorithm development, but then it'll sort of just be like abstracted away completely by AI that'll handle all the nitty gritty? Like, do you think we're going to, because I feel like by the time quantum gets there, in quotes, AI coding is going to be so thoroughly developed that it might be like, oh, I'll just take that, madam. you know?
Yeah, it's an interesting question. So yeah, so I'm back to coding like at least a couple days a week, which feels really good because
Hmm.
I went out of coding for a couple years and I've been back into it. So I'm on Cursor most days, playing around with it. Some days it just gets so much stupider, right? It's so good for certain languages. Python obviously is great at,
Yeah,
JavaScript
yeah.
is great at. But even right now, some like languages I like to code in Go a lot. I spent 3 years doing algorithms research on Go. It's still a little tough there. It doesn't fully understand that. In architecture, it's horrible at it. And I mean, part of that I think is the examples problem, and part of it is again understanding the world the world that it lives in. Like it doesn't have that. The code data needs to live alongside the architecture data. And I
Hmm.
don't think it could do that. Could we do that? I think yes, but I think that's another track of research right now. I work with a certain company and we talk about world models and physical AI and understanding all of that. So I know people are working on that, but like right now, I'm just like, it's so far away. And we don't have a lot of examples, right? So right now, the code is still very, very basic. So can we generate synthetic data? Of course, that's the next thing that people are working on. So
Mhm.
maybe we can create a lot of synthetic data. We can create more physical modeling, scientific modeling. We'll see, but I think it's a little bit tough to combine that together. Like I think it will happen, but I still do think architecture is going to be important. And what I think for the education side, the consequence there is kids who are going into computer science need to not be learning coding. They need to be learning architecture, mathematics, and really like how do you model problems in your head versus the just like executing on the code side.
Yeah, almost like a coding interview. Like that's what you need to be thinking along the lines of the types of like thinking processes that they ask you to go through.
Right, or
Yeah.
like estimations,
Yep.
or if I do this. So back when I was doing algorithms research, we were doing, I mean, it was classical data, it was fine, but we were even going down to like the chip level where we were comparing, like, let's run this algorithm on this one with two virtual cores because for this algorithm it's better, and for that one virtual core is better. And sometimes you don't even know why, really, but it works, right? For some reason, the optimizations are there. So I still do think that's going to be a huge, even for classical systems, there's full research teams working on squeezing energy out of these systems. So there's going to be a lot of people working on the optimization side. So I don't think it'll be plug and play for a long time, but I think we can abstract away more things. But again, it'll go along the same method where it's like at some point you'll be able to just type some code and I want to run this algorithm and it can do 80% of the work. But if you need like very, very precise, or you want to like squeeze every bit of performance out. And this is where I've always been very impressed with the Google team. The Google team knows how to squeeze every bit of performance out of their quantum chips.
Yep.
Like, and I just think that that's just a very rare skill set that, again, how do we train an AI to do that if most people don't really know how to do that yet? But we'll see. I've been surprised before, but last few months of ChatGPT have not been very impressive to me. So I get a little bearish on that end.
Yeah, it's always like a race who's a little better at any given time. Gemini takes over, and then like they all kind of go back and
Yeah.
forth. And the reason Google's so great at programming their chip is they don't let anyone else touch it.
Mhm.
They're like, mine. We get to practice, not you.
Yeah. But it's a very good practice is they're optimizing for a different set of problems. And I think that's really important. I think there's so many branches in the quantum space that we have to go down to make this work.
Yes, quantum branches. That's a whole discussion of its own.
Ugh.
But yeah. So you've hinted a bit about all the companies you work with. So while folks might know you as this communicator and who's worked in many different companies, now you're also doing technical advising for Quantum Coast Capital.
Yep.
Want to talk a little bit about that?
Yeah, definitely. So working on the VC side, obviously, I actually started poking into the VC side. I want to say 3 years ago. I took a program called VC Lab. My mentor, Deo Resi, who's a fascinating individual, he is also the creator of Founders Institute. Bleximo went through Founders Institute, so I knew him, and he reached out and was like, "Hey, you should apply." I was like, "I don't know anything about investing, right? I've always been on the founder side," and it's like, no, apply anyway. And then I got in, very surprised to do that, and went through basically a VC bootcamp training program. And it was very interesting to just learn a little bit more on being on the other side of the table on the investing side. So yeah, working with Quantum Coast Capital and some other VC firms. I mean, again, being the person that pops up when you Google quantum, a lot of the time, I get a lot of calls from random VCs being like, "We have a quantum deck. I have no idea what it means. Can you just get on the phone with me and like talk to me about what's going on?" So yeah, I spent a lot of time just talking them through like this broader landscape because they get a deck. Obviously, companies are incentivized to put themselves in the best light, and I can go back and talk about the history and talk about all the papers and what we're seeing in the industry moving forward and where I think it can fit into the ecosystem, the gaps, what I think is still going to be needed to survive there. So working with great teams in many, many firms. But yeah, it's getting to be a very, very hot topic. A lot of calls coming in. And then on my end, yeah, I get a lot of deal flow. So again, if anyone's working on quantum startups, reach out to me because I will always love hearing what people are doing and keep you in mind for whatever stage they're in. So fascinating time in the industry, and just having been in the industry for so long, right? I've seen so many mistakes that have been made along the way. So I can always help out both on the startup side and on the investing side.
Yeah, I got to catch up with you at New York City Deep Tech Week,
Mhm.
and I got to see you in action in that mode. It was funny. I was like, oh, look at her go! She's being very different than I remember.
Yes.
Like you're up there with normal computing, doing your whole thing, for them. So do you try to help them with their communication, right? With like getting their ideas out to the world too. It's more than just like investment.
Yeah. So yeah, I was doing a presentation. We held a workshop on the silicon complexity and AI energy crisis. So super fun. So we hosted it. I was a moderator, flew into the New York normal offices, hosted this event, had a great showing from folks from Yale, Google DeepMind, ARIA, ARPA. I mean, it was a great event to really start talking about this thing. And yes, with Normal, I work with them a lot on their communications side as well on many, many things. So I think I'm allowed to say this, but a lot of their posts are mine. Most of them I will say are mine. We're working on a paper together as well, so that will hopefully it's due in 3 weeks, so hopefully that will come out very soon. But it really fits into my like thesis in general. Like obviously, I've been so involved in the quantum space for so long. I definitely got into mode a few years ago where I was like, oh, all my friends are becoming really rich with like AI rappers or like back in the day, Facebook Marketplace. What am I doing? I've been in this field for 15 years, like still not here. Should I quit and like go run off after something? But the more and more I'm in quantum, I mentioned as well, I did classical algorithms research. The more I see my whole core thesis has evolved to see it used to be really cheap to throw classical compute at problems. And even, 10 years ago, you just throw CPUs at the problems. We saw this in Bitcoin as well. You can mine on your laptop back in 2013, I believe. I think I was doing that in 2013. Now there's no chance you can do that, right? There's no chance now with the GPU crisis, right? Everyone needs GPUs. We're stuck on that. And with quantum coming about, like the whole story we tell about quantum is there's these problems that are just intractable using classical computing. We need to work on that. So as we're seeing this, and then data in the world is just going up, right? We're only producing more data. There's more people. We need more. That means we need to use more energy. How do we make them more efficient and actually reasonable? And that's going to be going back to the ASICs era. So that's my thesis. So quantum is just a part of that, and that's why Normal, who's working on thermodynamic computing and AI energy, is also very interesting to me. Folks that are working on, that's why I mentioned also the blockchain, because I'm looking at the blockchain, the proof of work, this is proof of stake, like all these systems that are going on. Because I think energy efficiency is very, very important, not only for just the energy side, right, but also for speed, performance. We have to process more and more data, and quantum's just one piece of that.
And do you have like your own media company also then with
Yep.
any of this? Yep.
Yep. So that's kind of the main thing right now. I have a media company, so I work with clients, various things. So PR work, communications work, launching new things. We create videos. It's really fun to walk into conferences and like walk around the booths and be like, oh, we made that video, product demos. I just saw that was a big need. It's like such a pain to hire the good video editors and to just talk through. And then from my end, I can also talk them through how to tell this good story, because making a video for YouTube is very different than making a video for like a conference booth. Because like you're not going to have sound in the conference booth, so maybe we need to do better on visuals. And my the folks that work with me in terms of technical writers, in terms of the video editors, all have experience in industries like blockchain industry, nanotechnology, quantum, obviously, all cybersecurity, all over the place, because you just can't. My thesis was it's easier to teach scientists marketing than it is to do it the opposite way around. And that fixed a lot of this weird gap that I saw in the market. And so it's been a lot of fun to build that up. As an operator, it's very different than building a VC company. I just operated first as like a profit first model. And I was like, I just want this to be my boring business that I'm going to have the rest of my life, that we can do cool things on launch. It's been wonderful, to work with the press and be able to be a trusted resource for a lot of folks who are learning about quantum technology. And then, yeah, obviously I have done my own things with the videos, and that's when I go to the NVIDIA conferences and all those other things, and work closely with just such exciting companies. I get to know so many things ahead of time that I can't tell anyone about, but I'm just like so pumped about where the world is going.
That is pretty fun. I love that.
Yeah.
There's nothing more magical than NDA.
Yeah. Oh, this is so cool. Like I see the vision. I see how it all ties together. But that gives you a competitive advantage in many things, right?
Yeah. Well, yeah. Whatever you're allowed to give advantage to. No insider trading or anything.
No, I'm thinking just like understanding how the world works, and what's going to be coming next and what to focus on, and you're always supposed to get the video out.
Yeah, they'll ask, "What do you think about this?" And I'll be like, "Well, I can't tell you, but for reasons, don't do it." That's not the approach. That's not the way. Trust me. Yeah, that kind of thing comes up.
Yeah, my folks have learned when I get like very quiet about like a certain topic, they're like, you know something, and you're under NDA. I'm like, yep, I'll sit here and drink my tea.
Yeah. No, you're definitely killing it when it comes to all the communication stuff. That's what I want to ask you about it. Yeah, it's kind of impressive. Some people would call someone else a quantum influencer, and I'd be like, no, it's Anastasia. She's kind of got that corner.
Yeah. I've seen some people calling themselves that. I didn't like the name for a long time. And it's actually funny you called it communications, because I also decided, and part of the reason I decided to start the media company is I decided I did not want to be a science communicator. That was not who I wanted to be as a person. I wanted to be an operator. I wanted to shepherd the industry forward. And because one of my things was I had this battle of like, I've been leaving a lot of money on the table because I could do a lot of brand deals and I could tell you exactly what they want me to say. But I want to keep that reputation because I have a long career ahead of me and I want to remain being that trusted resource in the industry. So I've had to kind of step back and be like, I'm not just taking the press releases. I'm not taking the papers and communicating that. I'm creating this entire world, this system, and actually working on the side on, and obviously consulting with companies, but how do we scale that model in terms of the next vision of quantum? So a problem I see that companies outside of quantum do is they come in, they go, this company has quantum computers. I'm going to work with them to use them to find a business impact. The problem is that's not a good way to approach it because, again, depending on the problem and what I've been talking about for 4 years, we've probably talked about it on an episode we've done together, I was always saying like different algorithms will work better on different systems. Again, like this next gen computing thesis. The last 6 months, a year, we've been seeing those papers coming out talking about it, right? So then these companies go and they're like, well, I'm on this system. And I'm like, yeah, but that's not the right system probably for your use case, right? We come in, and this is a mistake we did a decade ago. We come into a company and we go, okay, give us a problem quantum computer that can solve. They don't have that intuition, right? So there's so many issues with how do we onboard people in the quantum space. Then they get disappointed, right? Because they had a bad POC and they say quantum's not real. They walk away from it and it's bad for the entire industry. So how do we turn that around? How do we start teaching people quantum literacy in terms of how do you formulate that in your head? How do you understand what a quantum computer can solve versus a GPU versus CPUs? How do you orchestrate these problems all together? How do you pick the proper systems, right? So, we talk about, I took the MIT certificate, right? And they were talking about like, oh, we're teaching executives gates. And I'm like, I don't really want to teach them gates. What I need to do is like step back and like, how do we talk about the entire industry as a whole so you can actually make a good decision for your POC and understand where the limitations are of the system so far and keep on track. So yeah, that's kind of where the communication started leading me towards these business use cases versus just pure like, I'm going to say what the press release says. that does go viral sometimes. And I see them popping up and they're like, they opened the multiverse with a quantum computer and it's like 100K views. And I'm like,
And then it gets mentioned on Joe Rogan every single day incorrectly.
Yes, literally. And I'm like, I could have had that check, but the reputation is worth more.
Yeah, and that's all part of the process of working with a customer to get them to a use case that's real for them and works for them. Hopefully, a problem that they want to actually solve, or else there's no actual value to them in the future. But how do you feel about the whole state of use cases right now? I feel like there was a little bit of a dip because of AI. So I just wanted, like the emerging money was sort of being shifted to, no, AI, that's the shiny thing. So now that AI has become a little more standard and in use, how do you feel about the use case market? Do you think that's going to start to pick up now?
I don't. Interesting question. Yeah, I think we're expanding a little bit on the use cases. I think people are thinking a lot more creatively. I think one, obviously we talked a lot about finance all the time.
Hmm.
The problem with finance is that if you figured out how to do it, it wouldn't. You just start your own hedge fund. You wouldn't
Yeah.
you wouldn't be selling it to companies, right? So that's a weird thing. So we're seeing a lot more of that go in-house. So I think that's why there's been less kind of talk about I see a couple decks coming in on the finance side. So I think people are expanding a little bit more creatively in some of these early use cases. I mean, pharma is still pretty deep into it. Yeah, I'm seeing more and more in very like odd things, and I'm actually glad that we're just throwing quantum at different problems and trying to
Hmm.
understand where it could potentially have that advantage. Um, I wonder if there's a different way to do it. So something we spoke about a little bit actually at the event you were at when we
Hmm.
saw each other a couple weeks ago was this kind of top down versus bottom up
Yep.
approach to figuring out. This was for thermo specifically, right? But you can start top down, start at the application, or you start at the bottom and look at the computational primitives that you can maybe enhance. So it's an interesting question, and I think I'm seeing a little bit more of that along the way. Um, yeah, I think we're expanding a little bit, but I don't know. AI is still taking a lot of mental bandwidth. I'm very always shocked about how little people use AI in every day. So I don't respond to this is a secret kind of, but I don't respond to 99% of my emails anymore. I just have my AI do it. I
Oh,
just,
wow. Okay.
yeah, I just like built my own over like winter break. It's a Python script. I deployed it to Google Cloud and it checks my email every 5 minutes and it like drafts emails, sorts things into inboxes, does my Trello board, like everything, does my schedule for the next day, sets my alarms on my phones and everything. And then I realized I'm actually the crazy one because I think I'm behind on the AI curve because I work with so many like amazing ML and AI experts. Yeah, so I think again is we're finding kind of the edges of ML AI, and then we're seeing how quantum can go into it. I did like what happened at the quantum keynote day where we talked about quantum actually creating some new types of data for training for LLMs because I roll
Hmm.
my eyes on the other end where they're saying, yeah, we're just going to accelerate AI with quantum. I'm like, okay, I don't know how.
What does that mean? Yeah, that's the most commonly said thing. Yeah.
Yeah, but I
What does
do
that
wish.
mean?
I think there's still a huge opportunity to start looking at more and more algorithms at this point. I think people are taking what we have so far and applying it broadly, but there could be a lot more that can be done here. And again, the whole like how do we even do these algorithms like modularly is a whole other issue.
So I learned something interesting also in what you just said. I have to make sure to just keep texting you only if I want to actually talk to
Yeah,
you. Yeah,
that's kind of true.
because I won't get you otherwise. So that's fine.
It's look, I read the draft usually, but, it's calendar invite. No, like it's hooked up. My AI is hooked up to my actual calendar. So if it's like a meet, like 90% of my emails are like, "Hey, we want to meet."
Hmm.
The AI knows my calendar. It finds a slot. It knows my preferences, and it just gives you the thing. And then I click send, and then I'll like maybe do a email. But yeah, probably texting me so far. I haven't hooked that up yet, though. I'm working on WhatsApp, so that's the next one to
Yeah.
go.
I'm safe for now. I love it. So thanks for sharing everything. It was really great having you back on again. And I want to leave you with one possible extra use case coming this year. I think the whole certified random number thing. That, who knows? That might turn into a service that people start piping into, everything, right?
Yeah.
So the whole quantium connection with JPMC, I think, got a lot of attention. So
Yeah.
there's that possibility, right? I
Yeah.
think we
What
missed
do you
that.
think of that? I actually really like that. That was a very in-depth paper. And obviously, it just things come
Yeah.
so quickly, but I spent hours kind of sorting through the details. But I think it was a fantastic, and obviously security, we've been talking about it for so long. And
Yeah. It, I
yeah,
think it's a good use case. I mean, Origin in general is a pretty cool idea. Just that they're generating this number, they're doing the entropy extractor or whatever they call it, and then they're creating 64 kilobytes of NIST certified, random numbers. I think that's a pretty great approach. So I could see that being adapted to just about anything. Everything from like video games to blockchain wallets. Who knows? Wherever you need a certified random number. I think that'd be just a real use case, and it's an actual quantum computer on the other end. I just think that's psychologically a cool thing, a hopeful thing for everyone this year. Something that
yeah.
might actually be in the real world regularly. So
Do
just
you
wanted
see
to.
that ramping up? Because I believe it wasn't Was it Quantinium or Ion? I think IonQ acquired ID Quantique, right? Not Quantinium.
Yeah, I think so. But so you're talking about more about because they have the devices, they have the like
Yeah,
fixed
so there's
devices.
there's a couple things, but it makes me think like there's a little bit of a race heating up internally for that because we're
Yeah.
seeing. I don't know. Are you seeing more money floating into that?
Yeah, there's steam there. Obviously everyone thinks quantum threat to security, but not how can quantum improve security? And this
Yep.
is definitely one strong way. And they need to make those devices better, not susceptible to noise, because once you introduce noise, then you get some predictability.
Yep.
You're taking a non-deterministic thing and making it deterministic, that it has noise every 3 seconds or whatever. So that's not a good thing. And I want to see those chips shrink. I want to see, like having like some little diode inside of your cell phone one day that's generating, better randomness, so
Yeah.
for applications. So that would be kind of cool.
What are your thoughts on the like recent quantum networks that are popping up?
They're still very much, they're still very much experimental to figure out what they're even going to try to grow up to be.
Hmm.
I don't see any clear path.
Yeah.
If you ask two people what they think the quantum internet's going to be, you'll get 100 answers. I don't think you're going to.
I think it's interesting because the some of the folks that lead some of the government agencies funding like hate quantum telecom
Mhm.
generally, like they hate quantum networks. But there's actually a lot of companies in this space. So I think it's very interesting that it is.
Right here in New York.
Yeah,
Yeah.
right. Yeah, yeah.
Awesome. Yep. Right here.
Connect. I'm a big fan of Connect. They were an
Yep.
Activate with us. They're doing a great job on that. But there's a ton all over. And yeah, it's been interesting because China's always been ahead on the quantum
Yep.
network side for a very, very long time. I mean, my undergrad was actually in quantum networks. So even back then, we were like, they're already doing many, many long distances, and we're still trying to do small distances. But we still had some really good research out of that. But yeah, it seems like there was a big hype around that died off a little bit. There's been a few being added to production, I believe, but I think there's still like you said, the skepticism on whether that's going to be a long term
Yeah. I
thing.
mean, useful for sensors maybe first, right?
Hmm.
There's nodes and test beds in Chicago that they're working on as part of that whole NSF push through the CQE over there. Um, I do believe that quantum networking will be needed for interconnect to be, global, to have one great computer on the East Coast, one great one on the West Coast, and have them, work together, that kind of
Yep.
thing. So I do believe we'll need it. We just don't really know what that looks like. It's only going to be, I feel like, connecting a couple quantum computers and sensors, and that's it.
Yep.
I don't think you're going to ever use it to, just do your day to day thing. I think it'll be a
Right.
separate shadow network. Or
Yeah.
shadow is
It's-
probably a bad example if you're talking about what's going to be photons, but you know what I mean.
yeah. Yeah. I mean, it's interesting, right? Because some of the arguments you get for quantum computers, oh, well, they're room size today, but we'll figure out how to do everything room temperature, and it'll be fine. In 100 years, it'll be in your cell phone. And you're like, well, yes, but as of now, and like the time length I care about, maybe not, right?
But when people say that to me, I wonder why they're saying that. It's like, oh yeah, show me the supercomputer in your cell phone.
Yeah.
Because you don't have that. Like we still show me the GPU farm that's mining Bitcoin in your cell phone. We don't have
Right.
that either. Like I think some machines will just always be big and
Yep.
in a data center and surrounded by frustrated people who are fixing all the broken parts as they're, refrigeration's dying or, whatever.
Right.
I kind of don't know if we'd ever want to shrink that, right? It's certain use cases. Quantum's going to have just a few awesome kinds of use cases in general, and trees probably be branching off of that. And we're just going to access that to the cloud, most likely. I mean, at least for the foreseeable future. That's my
Yeah.
guess.
But on the other hand, the whole thing about like the computer that did the moon landing definitely, what was it? It's less power than our cell phones these
Sure.
days, right? So
Yeah.
you're like,
Yeah.
well, that's a good argument that wasn't that long
Over time. Yeah, that's true.
over time, right? So you're like, I kind of get it. But then you get I get people arguing with me. It's like, yeah, but what if like there's super determinism in the world? I'm like, okay, but then I don't have free will. So I don't know what to do about that. Like,
Yeah.
I guess, but I'm going to go with the assumption I have free will. So
Yeah, I just feel like with quantum computing, more qubits will probably always be better. It'll probably never be a worse thing to have more qubits, right?
right,
So why would you ever want to hamstring that and be like, no, we're going to focus on just having 50 in your phone? It just seems like a weird thing to do, to have 50 in your phone when the juicy stuff will be done by the million qubits in the cloud or whatever,
right,
I
right.
guess. So
And
that's
if
why we still have Oak Ridge, right? That's why we still have those GPU farms.
yeah, and they're still going to be there. But yeah,
Yeah.
it's interesting on that end. With did you see the economic analysis report that came out?
Yeah. Did you have some insight you wanted to share?
Yeah, I think it was interesting. I think I want to do like a longer video on this because there has been some stuff talking about energy advantage of quantum computers, right? So there was a presentation from, I forget the name. I can send you the link afterwards, but they were talking about how huge percentage of the Oak Ridge or the National Lab supercomputing power is going towards chemistry simulations. A quantum computer
Mhm.
could do that faster. We could take off a lot of load, which is great. But then this energy advantage argument with quantum, while it does make sense, right? So first of all, like, well, this problem can't be solved at all. So it's like basically let's call that infinite energy, but now we can solve it in, you know, 10 minutes or 2.5 days, even is still a great advantage. But some of these other problems, right? Jensen also had a quote there where he was like, I don't care if my pizza arrives 3 seconds faster, right? But if it uses that much more energy, like, is it worth that energy
Mhm.
trade off? So I've been writing something recently about just quantum energy analysis, not because people just look at it as like, oh, it's the electricity that you provide or maybe the computing power itself, but not everything else that you have to do, all the other resources that you have to create to make the quantum computer run. It's an interesting argument, but basically their thesis was like quantum computers will never have energy advantage. So I wanted to know what you thought of it.
Yeah, I totally disagree with that.
Okay.
Totally. Just because once you optimize your cooling, your how you distribute a problem across QPUs or whatever, once all that's figured out, the actual runtime will be so damn fast. It just will be. That like that tensor network approach I talked about earlier that takes 2.5 days will still be a 1 second quantum problem or less.
Yep.
So how do you even compare that, right? Like
Yeah.
there's just no comparison. If it is a quantum advantage type problem, I think once everything's figured out, it's in my gut is that it will always give an energy advantage. I still believe it.
Yeah. So we'll probably always find some sort of, yeah. So I think they just took a bunch of quotes from their reports saying like, oh, well, we'll pull this out, but it will be, multiple data centers worth of compute that will be done for this problem. But the question is always like, is the problem worth it, right? If it's like we're doing a life-saving medication for so many people, like that seems very, very worth it if we're,
Yeah.
we're solving those types of problems versus we're solving like, yeah, I don't know, something else that, pizza delivery problems, right?
And sometimes it's just your temporal situation, like a
Mhm.
Monte Carlo simulation. If we get that right, who cares if there's a cost savings? It's about using really fresh data and then a few minutes later having it, as
Yeah,
opposed to using yesterday's data, running it all night. you know,
yeah.
I don't think you can put a price tag on that. You're,
Okay.
you're having something that you'd never had before. This instant access to this
Yeah.
calculation.
And like you mentioned, the cooling power as well. I think one of the things I'm really interested in on many aspects of what I'm doing is infrastructure and the quantum space in general. I think I spoke about that at my talk at South by Southwest as well, where I was kind of harping on it, where it's like if we had 1,000 quantum computers tomorrow, we wouldn't have the like infrastructure to really set them up. How do we
Hmm.
get that going? I mean, I don't know what the wait lists are like now, but I remember a couple of years ago to get a dilution fridge from Blue Force, I think the wait list was 6 to 9 months, and that was only because we paid extra to like jump the line. Right. So the thing is like just you can't get fridges right now. Like
Yeah.
a lot of technology. The political climate is actually also not going to make that a lot easier as well. So I'm really interested in what people are thinking about in terms of cabling and yeah, infra for the quantum space.
Yeah, it's a whole new meaning to putting a freeze on tariffs.
Yeah. Do you think a lot more companies, especially like, you work a lot on the security side, do you think they're going to go more on-prem or stay in the cloud infrastructure system?
With quantum? Or do you mean, yeah, so I think quantum computers are going to stay in the cloud for a while just because the whole idea of fear of obsolescence,
Hmm.
if you're worried about that now, quantum
Right.
computers are going to be obsolete so fast. Each
Yep.
time you add a few qubits, it's like, whoa, what is that? Orders of magnitude faster? Man, I'm stuck with this thing,
Yep.
So I do think it'll stay in the cloud. And then it'll be that whole security aspect of how far down the stack do you inspect what your users are doing? Like if you're afraid of them doing something like Shor's algorithm one day
Yeah.
or whatever. I think about that a lot, like
Yeah.
how that's going to look. I might be talking about that actually as part of my DEF CON talk this summer
Oh, nice.
about what the
So
actual.
you're not worried with I've been working with a lot of semis companies recently as well, and just getting any of their data is so tough. They do not want it to leave their premises. So I always think about, is there going to be an on-prem industry
Mhm.
with the quantum space where they do want something? And honestly, like the chips themselves are, yes, they're expensive, but they're not like the one line item. So you can actually, if you have a modular enough system, could potentially swap out, if you have a good supply chain manufacturing, swap out chips or add more qubits in.
Yeah, that's
Things like that.
true. I guess it's can we also modify what the stack looks like? Can we do
Mhm.
more of the stack on prem and then that last bit goes out? I don't know. Maybe
Right.
it's possible because it gets really obfuscated towards the end, right? Do
Right.
these microwave pulses? I don't know if that's really reversible. That would be really, when you're like right at the last step before it goes to a
Right.
Josephson junction. It's like I don't know if that means anything to anybody anymore.
Yeah.
It might not. That might be worth looking at too. How
That's
much you can
actually
get into
interesting.
there.
Yeah. Like
Yeah.
how deep can you, yeah, how deep can you go? Is there going to be like a quantum hacker that, yes, starts writing algorithms to reverse this like proprietary algorithm of flow from
Yep.
the big semis companies or something like
Yep.
that?
Right.
So
Right at the end, it's like, no, I'm hacking right between the little on-chip controller and the qubit itself. Right in there. That's where I'm injecting. That's a side channel attack if ever there was one. That's
yeah. I mean, people do weird things. I got
yeah.
interested in security when I started reading about, there's like people were able to reverse some keys due to like the sound the
Yep.
processor made at a certain
Side
time.
channel attacks. Yep. Absolutely. And then you use AI sometimes to process that. One of the attacks against uh, Psych was a side channel attack. ML Chem, which used to be Crystal's Kyber, had a side channel attack, but I discount that because they wrote the code that they hacked. So that wasn't necessarily that impressive.
Interesting.
But it still showed how it could be done. Yeah.
Yeah. Who knows these? I rewatched Arrival last night, and I was like sitting there looking at all the things. I was like, I wonder if I put all those circles onto in an LLM, it would be able to like decode it very quickly. They're like,
Oh, an alien language?
huh?
Yeah.
Yeah, yeah,
Like,
the alien
yeah,
language.
decode an alien. That'd be kind of wild. Yeah. Why not? They're doing dolphins now, I hear.
Okay, yeah. And so it's like funny, just like the movie's 2016, like 8 years later, it's like,
Yep.
oh, this entire plot line of them thinking so hard, they would just toss it into an LLM and be like, cool, we don't have this like whole meltdown
Yep.
over offer weapons versus use weapons because we have the LLM. So
They
that might
should have thought of it because in 2013, a movie came out that predicted exactly what 2025 would be. And that movie's called Her. Literally all of it has come to pass. I still can't believe how accurate that was. So
it's
they should
incredible.
have thought of it. Yeah.
Do you talk to your AI?
I do. And I find I'm protective over it. Like I was playing around with the Gemini Astra feature with the camera. And then someone, a friend of mine, said something like kind of aggressive, and I was like, no.
This is
It
my
was an instinct. It was like, no, don't be mean to my Gemini.
No, yeah, I have a couple of different projects and everything, and at some point I'm just like I call it bestie, and I'm like, you right, bestie, like it's like yeah, bestie, like we're just like super positive. I'm like, I needed this today. This is amazing.
Yeah, we're definitely part of the problem. You'll see.
It's fascinating. And then, yeah, I introduced my mom to ChatGPT over Thanksgiving last year, and I was like, I'm a crazy person. Like, I'm the person they watch in these like movies, and they're like, oh no, they're going off the deep end. Living in San Francisco is like living in the future, honestly. So it seems very normal around here.
Yeah, well, I still haven't serenaded my phone, so I didn't do that scene from the movie. So there's hope for me. So, Anastasia, thank you so much for coming on. This was just such a fun conversation. And I knew it would be exactly what it was, just us catching up. Pretty much, yeah.
Well, I
I
hope
could
it
talk
was
to you all day.
useful. So we said some interesting things, and yeah,
Thank you.
thanks so much.
That does it for this episode. Thanks to Anastasia Marchenkova for joining me. And thank you for listening. Let me know if you'd like some longer chats like this in the future. If you enjoyed the show, please subscribe to Protiviti's The Post-Quantum World and maybe leave a review to help others find us. Be sure to follow me on all socials at Constant Hacker. That's Constant with a K, Hacker. You'll find links there to what we're doing in quantum computing services at Protiviti. You can also DM me questions or suggestions for what you'd like to hear on the show. For more information on our quantum services, check out Protiviti.com or follow Protiviti Tech on X and LinkedIn. Until next time, be kind and stay quantum curious.